Hello guys, today we'll be going through the memory shortcuts and analogies for periodic table. So if you haven't already, join our Telegram channel. You can access these memory shortcuts and analogies for free. And I sometimes also host crash courses for free. Yeah, and you can register. All right, so without further ado, let's get started. So groups, right? I like to think of them using this neighborhood analogy. So in my neighborhood, right, there are two coffee shops, and each of them are just 400 meters away from my house. Okay, so my house is here, and then each coffee shop is just 400 meters away. So whenever I need my teh or I need my kaya toast, I'll just go to one of them, right? It's so convenient. But it's not just me. Everyone in my neighborhood, everyone who lives near me, they follow a similar routine. We all shop at the same supermarket, right? We queue up at the same hawker stores for chicken rice, and we also grab breakfast from the same coffee shops. So it's like we all share the same habits because we live in the same area and we have all the same options around us. This is just like the groups in the periodic table. Why? Because the elements in the same group, right? They share similar chemical properties, just like how the people in my neighborhood, they have similar routines. But why? Because elements, right, in the same group, they have the same number of valence electrons. And the valence electrons is actually what causes uh, them to have similar chemical properties. The valence electrons are in charge of all the chemical properties. So they will react in the same way as well, which is similar to how my neighbors and I, right, we go to the same places for food and groceries. Okay, same chemical properties. Then what about periods? I like to use this school analogy. So you know how in school, right, we are divided into grades based on our age. Everyone in the same grade is around the same age, and we all study the same syllabus, right? Like for example, you are probably Sec 3 or Sec 4 right now, and you will study the same syllabus as everyone else in your class. Okay. It feels like we're all at the same level, right? We are taking similar lessons and challenges together. But as we move up from primary school to secondary school, for example, things get harder, right? Primary school was much easier, but now secondary school, the expectations grow. There's tougher exams and bigger projects and even leadership responsibilities, right, in your CCAs. So every year adds a little more weight, but we all handle it in our own ways. Even though we're in the same grade, our personalities are also very different, right? Some of us love sports, others are into art, and some are even passionate about science. So it's like we come from different backgrounds, with different families, each with our own strengths, even though we are learning the same material. So how can we relate this to periods in the periodic table? All the elements in the same period have the same number of electron shells. Okay, for example, this is period 3, okay? This period that goes all the way here. Period 3, right? All the elements in period 3 will have 3 electron shells. Okay, then all the elements in period 4 will have 4 electron shells. So they all have the same number of electron shells. Just like how the students in the same grade, they share the same level of knowledge. But as you move across a period from left to right, the elements become heavier. Okay, so let's say from potassium all the way to krypton. Krypton is the heaviest with the highest atomic mass, and potassium is the lightest. Okay, so from left to right, the elements get heavier, the atomic mass gets increased. Okay, just like how students have to take on more responsibilities as they move up each grade. And their chemical properties differ because they belong to different groups. Okay, just like how each students, they have their own unique personality. Okay, so remember, in the same group, they have similar chemical properties, but across a period, because they are all in different groups, all the elements are in different groups. For example, potassium group 1, calcium group 2. So they will all have different chemical properties. Okay, so that is for periods. That is how I understand periods. All right, moving on to trends down group 1 elements. So this one, some people find it hard to remember. So I have a memory shortcut for you guys. So firstly, group 1 elements, they are called alkali metals. And there are some trends down the group, specifically 4 trends down the group that you need to know. So the memory shortcut is DARM, DARM, and then plus, 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 minus. So just remember everything plus except for the last one. Okay, so what does plus mean? Plus means increase, then minus means decrease. Okay, so D is for density. Density increases down the group. Okay, so let's look at group 1. Lithium, will have the lowest density and francium will have the highest density. Okay, in group 1. Next, atomic radius increases. So remember I said each period, right, they have the same number of electron shells. It actually increases down the group, right? Lithium has 2 electron shells. Sodium has 3 electron shells. Potassium has 4 electron shells. So it increases down the group. That's why the atomic radius also increases. Okay, next, reactivity increases down the group, which means that lithium will be the least reactive and francium will be the most reactive out of all the group 1 metals, right? And finally, melting and boiling point decreases down the group. So lithium will have the highest melting and boiling point, and francium will have the lowest melting and boiling point. Okay, so those are the trends down group 1 elements, DARM plus 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 minus. Okay. All right, moving on to the trends down group 17 elements. So the memory shortcut is mom cooks rice. Okay, then it'll be plus plus minus. So again, everything is plus except for the last one. So group 17 elements, they are called halogens. So let's look at the trends down group 17. M is melting and boiling point. So melting and boiling point increases. Okay, so if you look at group 17, you have fluorine, chlorine, bromine, iodine, astatine. If melting and boiling point increases, that means fluorine has the lowest melting and boiling point, or astatine has the highest melting and boiling point. Okay. Next, color intensity increases. So this means that the color of the group 17 elements, right, the color of the halogens, they go from lighter to darker. So the lightest one being fluorine, and then the darkest one is astatine, okay, which is actually black. Later we'll go through the colors as well. Right, then the next one is reactivity. Since it's a minus, reactivity decreases. Okay, so the most reactive one, the most reactive group 17 element is fluorine, and the least reactive is astatine. All right. Okay, then there's one more, which is not included in the memory shortcut, but you have to know as well. So why didn't I include it? Because you can actually link this based on the melting and boiling point increase. Okay, so the trend is physical state changes from gas to solid. Okay, which means that fluorine is a gas, then slowly somewhere in the middle, bromine is liquid, then finally at the end, astatine is a solid. So the physical state changes from gas to solid. But how do I link this? Because the melting and boiling point increases down the group, right? So since fluorine has the lowest melting and boiling point, it will be a gas in room temperature. Okay, and since astatine has the highest melting and boiling point, it will be a solid in room temperature. All right, so I can just link it to this, and yeah, I just link it to the physical state. Okay, so those are the trends down your halogens, group 17 elements. Okay, now moving on to the colors. Your group 17 elements, right, they are colored substances. So let's remember the colors in gaseous state. Your grandma buys peanut butter. Okay, that's a memory shortcut. So Y is yellow, G is green, B is brown, P is purple, B is black. Okay, so these are the colors of your group 17 elements in gaseous state. So the first element is fluorine. Okay, so fluorine is a yellow gas. Okay, it's a pale yellow gas in room temperature. So remember, all of these, I'm talking about the color in gaseous state, but not all of them are gases in room temperature. Okay, then green will be chlorine. So chlorine is a yellowish green gas in room temperature. Okay, then remember, the physical state changes from gas to solid. So now bromine is brown, a brown gas, but in room temperature is a reddish brown liquid. Okay, then iodine is a purple gas, purple in gaseous state, but it's a purplish black solid in room temperature. And the gas of astatine is black, and it is also a black solid in room temperature. Okay, so these are the colors of your halogens in gaseous state and in room temperature. Moving on. Okay, next, displacement reactions of halogens. So let me tell you a story. In a small office, right, there's a manager named Tom. And even though he had been a manager for many, many years, he struggled with making decisions. And then he also oftenly missed deadlines and couldn't lead the team effectively. And then came Jerry, right, which is a new employee who just joined the company 2 months ago. So even though he just joined the company 2 months ago, he was far more competent. He could solve problems quickly, he could communicate well, and then the entire team also respected him. So since the CEO noticed that the department wasn't performing well under Tom's leadership as a manager, he decided that it was time for a change, right? So the CEO promoted Jerry to the managerial position, okay, replacing Tom. So now Jerry is the new manager because he was more capable and more effective than Tom. So this is how I link it to displacement reactions in halogens. So in a solution, right, the more reactive halogen will displace a less reactive halide ion from its compound. So halide ion just means the ion of the halogen. Okay, so like for example, halogen can be chlorine. Halide ion will be chloride ion. Okay, and then it's from the compound. So the compound is like the managerial position, right? And then the less reactive halide ion is like Tom. So Jerry being more reactive, being more competent, he can displace the less reactive Tom from the compound. Okay, so it's like displacement. The more reactive displace the less reactive. Okay, so for example, chlorine, right, is more reactive than bromine. So you can displace the bromide ions from, let's say, sodium bromide. Okay, so you'll form sodium chloride and bromine. All right, moving on to group 18 elements, noble gases. So imagine an ice tray, right, with 8 slots for ice cubes. When all the 8 slots are filled, right, the tray is balanced and complete. But if you add more water to a full tray, what happens? It will overflow and it becomes unstable. And what happens if you take away an ice cube? Now the tray looks incomplete and uneven, right? Now you only got 7, missing 1. But when the tray has exactly 8 cubes, it's perfectly stable. So this is just like noble gases. There are 8 electrons, well, except for helium. They will fill their outermost shell completely, making them stable and balanced. Okay, why do I say except for helium? Because helium has only 2 valence electrons, but it still has a full valence shell. Okay, because it's the first shell. Right, so since they have full valence shell, full outermost shell, they are stable and balanced. So since they are already stable, here's the key part, they do not need to gain or lose electrons. Okay, they do not need to lose or gain electrons, so they won't form bonds with other atoms. That's why they are known as unreactive, and they also exist as monoatomic elements. So monoatomic elements just means that they are elements that exist as a single atom. Okay, one atom. So that is all you need to know about group 18 elements. Another important part will be the properties of transition metals that differ from group 1 and 2 metals. So obviously in the name itself, transition metals, we already know they are metals. So they will have properties of other metals. Okay, like for example, good conductor of electricity, malleable and ductile. But you want to know the properties of transition metals that can differentiate themselves from other metals. Okay, so firstly, your transition metals is from group 3 to 12. Okay, they are between group 2 and 13 over here. These are your transition metals. Okay, so the memory shortcut to remember the properties is very cute cats, VCC. So V is variable oxidation states, which means they can have different oxidation states. For example, this is FeO, right? Iron 2 oxide. In FeO, the oxidation state of iron is +2. Okay, then next, this is Fe2O3. This iron 3 oxide. So in iron 3 oxide, the oxidation state of iron is +3. So you see how it has variable oxidation states? It has +2, and then it can also be +3. So this is the same for other transition metals as well. Okay, this is just one example. Next, C, right, will be its ability to form colored compounds. So for example, copper is a transition metal, right? So one of the compounds it forms is copper 2 sulfate. Okay, and copper 2 sulfate is actually blue, which is a colored compound. And then another one, iron 3 hydroxide. This is actually a reddish brown precipitate. Okay, so these are colored compounds formed by transition metals. And finally, they can be able to act as catalysts. So for example, iron is a catalyst in the Haber process to form ammonia. All right, that is it for this memory shortcut video. I hope you guys learned something new and see you guys in the next one.